So let me hit record. I don't know if you looked at what we're doing this week, but we are covering sections 19, 20, 21, and 22. So covering modules 11 and 12, which might seem a little overwhelming, but hopefully it's not too bad. And this is why I don't think it's going to be too bad. Sections 19 through 22 are all financial sections. So credit card, interest, loans, 401ks. And so the concepts themselves are probably pretty familiar. I'm sure you guys, if you don't have a credit card, you've talked about credit cards, you've used credit cards. You know, you probably have money in a bank. You may or may not have a loan for a house or a car or a boat, you know, whatever. So the concepts themselves aren't difficult. It's the how do we make the math fit? That's going to be the challenging part. So hopefully we get through all of that today. And of course, as usual, there are plenty of extra videos to go with each section outside of this. So you've got 4 web work assignments, an Excel assignment. I think it's the interest assignment. There is a video. I will post that along with the live session video after class. 2 quizzes this week and a discussion board. So lots of work. Hopefully you don't wait till the last minute to get started. So we will jump right in. So credit cards in section 19. You know, I'm going to kind of give you the overarching. Usually I go into a lot of detail. I love this section. It's my favorite. But you know, your credit cards and the interest rate you get on your credit card is based off of your credit, right? Good credit comes from paying your bills on time, blah, 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 blah. Watch my other videos for more detail. But one thing about credit cards that really just floors me when we talk about the interest and the finance charge. So every credit card has an interest rate, right? And if you don't pay your bill in full at the end of the month, you have a finance charge based off of your interest rate. So I just bought new furniture and I financed 12 months, same as cash. So as long as I pay it off in 12 months, I pay no interest. Now I'm going to disclose some personal information, so bear with me. But I just bought a new house. So I financed roughly $3,800 worth of furniture because I lived in a tiny apartment and I just bought a huge house. Well, huge for one person. And so my minimum payment on this credit card is $134. And on the document, it had a spot. I just got the bill last night, which is why this is fresh. If I only make the minimum payment, that's it. If I only make the minimum payment, does anybody, I want to take guesses. How many years will it take me to pay off my furniture if I only make the minimum payment? Just throw some years in the chat box. Anybody want to guess? How many years? And maybe I should tell you, the interest rate on this credit card is 29.99%. So if I don't pay it off in a year, I'm going to pay a 29.99% finance charge. How many years? Come on, guys, guess. If I only make the minimum payment, how many years will it take to pay off that furniture? Nobody's playing? Really? We got a 29, a 12. My mom last night guessed 5. Yeah, Brianna, you're the closest and you're low. It would take 34 years for me to pay off $3,800 worth of furniture if I only make the minimum payment. Because after that first year, oh, Stacy, you're fine. After that first year, I'd pay 29.99% interest. And we're going to do examples to show how that interest rate can just screw you over, right? So credit cards can be fabulous. You know, like this credit card. It's fabulous if I pay it off in 12 months. But if I don't, it's financial suicide. And so that is something you very much have to pay attention to of what is this interest rate on your credit cards and how is that affecting you? So to me, I was floored. I mean, I laughed out loud. I have it all budgeted, so I will pay it off in a year, assuming nothing bad happens to me. But 34 years, I'm 36. That's another lifetime of me of paying off the furniture that I currently have. So crazy. So you never want to have a credit card that has additional fees, right? You can get free credit cards. But the interest rate and the finance charge is basically what we're going to talk about. So oops, wrong button. So let's go ahead and we're going to start with an easy problem here. Easy because it's one step. So again, with credit cards, and feel free to chime in with any comments, suggestions, whatever that you would like. But you know, so a credit card, you go out, you buy some things. Good rule of thumb, don't put anything on a credit card that you don't have the money to pay for. So I use credit cards as a way to gain points, right? I have points on all my credit cards. And then I use them throughout the year. I pay them off as soon as I get them, and then I use the points at the end of the year for Christmas shopping. And that works because I never carry a balance. If you carry a balance, like in this particular example, you are subjected to huge interest rates. And we're going to see how those interest rates can really, really get you. So we're going to pretend in this first example that we're carrying a balance of $1,200. And we have an APR, which stands for annual percentage rate. So that's important. Annual percentage rate is 18.99%, which is common. You know, a lot of interest rates, depending on your credit. On my one credit card, I have a 12.99% interest rate. But obviously my furniture credit card is 29.99, excuse me. So it's anywhere in between there. Okay, does anybody have any idea how to find the finance charge on this carryover balance? Any idea? I don't want to feel like I'm doing all the talking. But if we, because you know, a lot of people don't think about it. You get your credit card statement, they tell you what it is, and you just do your thing. So okay, let's talk through this. So it deals with this percentage rate, but the percentage rate is annual. And we know that you make a monthly credit card payment, right? I get that bill every month and I pay it every month. So how do I change this 18.99% from an annual rate to a monthly rate? How can I go from annual to monthly? That's our question. Anybody have an idea? Divide by 12. Absolutely. So this is kind of an overarching thing that we're going to need throughout the next 4 sections. Anytime you have an annual rate, you want to divide it by 12. That turns it into monthly because there are 12 months in a year. So you'll notice on the screen, I changed my percent to a decimal because we want to play with decimals. I divide it by 12. That piece right there in yellow is my monthly percentage rate. And then I'm going to go ahead and I'm going to multiply by my carryover balance. So if I take 0.1899 divided by 12 and I multiply by 1200, what is my finance charge? Trisha, you have a decimal point problem. You got the right numbers, but the wrong decimals. It should be 1899. Right. We're talking about money in the next 4 sections, so you always went around to 2 decimal places because we're talking about money. So if you carry a balance of $1,200 with an 18.99% interest, the next month you're going to pay an additional $18.99. Right? That's free money to the credit card company. That's why they want you to carry a balance, because they're going to get free money off of you. Right? And $18.99, I mean, I can buy a lot of food for $18.99. So that's why you kind of want to keep in mind. And I do this on occasion when I get my Visa bill and I'm like, I really don't want to pay the whole thing because I want to do something else with that money. And then I calculate how much my finance charge would be. And I never, no matter how low it is, I can't justify just giving away money when I have the ability to pay the bill. So it's something to just keep in mind. All right, so that's the basic idea of finding the finance charge. APR divided by 12 multiplied by your balance. So now we're going to move ahead to this piece. Now you are going to have the ability to, you're going to have to do this in Excel and in WebWork for your homework. So we're probably not going to do this entire table because we don't have time, but I at least want to do, the first 2 months. So Sarah has a balance of $1,400 with an APR of 20.99%. She makes no new purchases and she only makes the minimum payment each month, which is 6%. So we're going to complete the table. All right, we're going to talk through month 1 together, and then I want you to maybe do month 2 on your own. Okay, so the beginning balance, she's carrying a $1,400 balance on her credit card. Let's go ahead and find the finance charge. How do we find the finance charge? That's what we just finished doing. So remember the finance charge. We take our APR of 20.99%, change it to a decimal, and divide by 12. Then we multiply that by our beginning balance, which is $1,400. So what do we get for our finance charge? Again, we're rounding to the nearest penny. Okay, so the 0.2099 divided by 12 multiplied by 1,400 yields a finance charge of $24.49. Exactly. Okay, now how do you think we get the new balance? If we had the beginning balance of 1,400 and then we pay an additional to the finance charge, right? The finance charge is in addition to that. So we're going to add these two columns together to get our new balance. So if we add those two together, I get $1,424.49. The new balance is what we use to calculate our new minimum payment, right? So Sarah went through the whole month. She didn't buy anything else. So she just has her beginning balance, her finance charge, and now she's ready to make her minimum payment. So her minimum payment is 6% of her balance. So we would take the balance of $1,424.49 and we multiply by 6%, which is 0.06. What would be her minimum payment? $85.47. Very good. And again, rounding to the nearest penny. Okay, so she makes that payment. Now, how do we figure out how much her balance is at the beginning of the next month? Some of this, if you just kind of think through it logically, it makes sense. So like if she owed $1424.49 at the end of the month and then she made a payment, she owes what's left, right? So the $1424.49 minus the $85.47 would leave us with $1339.02. Okay, I would like you to finish month 2. So finance charge, new balance, minimum payment. Just those three. I'm going to give you about a minute, and then we're going to move on to the next section. So giving you a minute. All right, your minute is up, hopefully. Finance charge. What'd you get for the finance charge in month 2? 2342. Excellent. If you need to see how any of these numbers got here, let me know. Then our new balance, what's the new balance of month 2? Good, 1362.44. And the minimum payment, $81.75. Good. So you can see as you owe less, you're going to pay less of a finance charge, but then your minimum payment also goes down. I'm of the belief, like if this was my situation, if I could afford to pay $85.47 the first month, I would continue to pay $85. Just pretend that that doesn't change. The more you pay, the quicker your balance is going to go down, the less finance charge you're going to pay. And that ultimately is what we want to do. Okay, so in this section in web work, you're going to do things like this, and then you're going to answer questions about them. Like, what's the total of the finance charges? What percent of finance charges is the total payments? Those kind of things. Obviously, we're not talking about those right now. So if any of that troubles you or gives you problems, send me an email. In a lot of this stuff, you're going to use Excel. So if you're doing stuff in Excel and you're stuck, send me your Excel document. I can help you quickly if you send me your Excel document and I can look at your problem. So there you go. Okay, so that's section 19. We're on to section 20. And we're only a minute behind schedule. That's fabulous. Section 20 is interest. We're going to talk about simple and compound interest. This is good interest. So credit cards talk about bad interest that you're paying, the banks or the credit card company. And then now we're talking about when you invest money, so interest coming to you. So simple interest is I equals PRT. That is interest equals the principal being the amount that you start with, times the rate, which is an annual rate as a percentage, and then times time, and time is always in years. Okay, so with simple interest, there's your formula. By the way, these formulas are on the formula sheet that you had for exam 2. You will have the same formula sheet for exam 3. Okay, so we are now going to play with this formula. The thing about simple interest, it is only interest based off of your initial piece. So it's only found one time at the very beginning on your initial principal, and that's it. Simple interest is not used very much in the real world. Some car dealerships use simple interest on their car loans. Not all. That's about it in terms of real life experiences. All right, so we're back to Sarah. I must have enjoyed that name when I created this PowerPoint. But so Sarah invests $600 at 2.5% simple interest for 6 years. So first things first, how much interest does she earn? So remember, interest is principal times rate times time. So what's our principal in this problem? $600, exactly. It's the amount she starts with. Then we go to our rate. Our rate is our percentage, but we want to change that to a decimal, right? So we're going to have 0.025. Always make sure you're moving your decimal 2 places when changing from percent to a decimal. And then we multiply by the number of years, which in this case is 6. So how much interest does Sarah earn? $90. Very good. Okay, so now think logically. Part B, what is her balance after 6 years? How do we figure out her balance after 6 years? Because this is good money, right? She put $600 in an investment. It grew $90 over 6 years. How much does she have at the end of those 6 years? $690, exactly. So your balance is going to be your principal plus your interest. So she started with 600, she added the good interest of 90, and so after 6 years, she has $690. Right? That's simple interest. Mathematically, you multiply, you add. The math isn't hard, it's just remembering what the pieces are. So do remember that formula, I equals PRT, is on your formula sheet. Okay, let's go on to compound interest. Compound interest is a little bit more difficult simply because the formula is a little bit bigger. So your calculator is going to be your biggest issue. when it comes to compound interest. If you can't figure out how the buttons work, all you need to do is send me a picture. Take a picture of your calculator and email it to me, and I can send you what buttons to push in what order for compound interest, because I'm really familiar with all the general calculators. Okay, so the formula for compound interest, which is also on your yellow sheet, is balance equals principal 1 plus the rate divided by n raised to the t times n power. So we still have PRT, principal, rate, and time in years. Those things stay the same. But now we have this new friend called n. N refers to the number of times you compound in a year. So you might compound monthly, you might compound quarterly, daily, all of those things. So if I say we're going to compound monthly, how many months are in a year? 12. So n would have a value of 12 if the problem says you're compounding monthly. If we're compounding quarterly, how many quarters are in a year? 4. Look, you guys had that answer before I even looked at the screen. You may also find out that we're going to compound annually. Annually means how many times? Just once, exactly. That's the easy one, because if you put a 1 in here, it doesn't change your problem. So we're going to talk about how this works. You'll also notice that this formula finds the ending balance. It doesn't find the interest, it finds the balance. So we're going to have to work backwards if we want to find the interest. Okay, let's go ahead and jump into a problem. We'll see how our calculators work for this. So we are going to assume a $1,200 deposit with an APR of 3.5% compounded annually for 4 years. Okay, so we're going to start with finding a pen color. Oop, there we go. Okay, let me get the pen. So balance is the principal, 1 plus the rate divided by n raised to the t times n power. And depending on your calculator, some of you will need these parentheses in the exponent, some of you will not. So, okay, so the principal, we're starting with $1,200. Then inside parentheses, I have 1 plus, my rate is 3.5%. So 0.035. What am I going to divide by? If I'm compounding annually, I divide by 1. Very good. And then my exponent is 4 years times n, which is 1. Now you can see, since you're dividing by 1, you can type it in like that to your calculator. It's fine. But if that bothers you, because, hopefully you all remember that when you divide by 1, it doesn't change anything. So this is the same as 1 plus 0.035 raised to the 4th power. So that green equation and that yellow equation are really the same thing. So we'll see if we can't get that. And if you struggle with your calculator here in this session, don't lose hope. Just send me a picture and I'll send you a good detailed email of exactly what buttons to push when. It's worked. Other students have sent me those pictures and it's worked pretty well. So go ahead and, as you're typing those in and getting some answers on your calculator, go ahead and throw those in the chat box, and we'll see if anybody's having calculator success today. And remember, you started with 1,200, so your answer should be bigger than 1,200 because this is good interest, right? You're earning money. Yes, Amber, correct. 1377.03 is what you should have gotten for that balance. So after 4 years, the balance of this account will be 1377. So again, if you need help with your calculator, shoot me a picture, because that's about the easiest way to do that. Now we're going to do part B, which is the interest. So now we got to work backwards. If I started with 1,200 and I end with 1377.03, how do I find my interest? find our interest, we're going to take our ending balance minus the beginning balance. You can't use PRT on this one, Amber, because this is compound interest. It's different. So compound interest calculates interest on your most current balance. So if it's compounding annually, at the end of year one, you get interest. So you would get an interest payment, and then your account would go up slightly. And then so the next year, you have a bigger balance, so you would make more interest. It's kind of like the reverse of credit cards. So in credit cards, as you pay it off, your balance goes down, so you pay less interest. Well, when you have money in the bank or in an investment, as your balance goes up, you earn more interest. So whereas in simple interest, you only are paid interest on your initial deposit, compound interest, you earn interest on your most current balance. So every time your interest is added in, your balance grows, you earn more interest, if that makes sense. In your packet, there's a table that you work through, so I would recommend that. It really helps you show that. Okay, so for this one, if we end with 1377.03 and we started with 1200, that means the difference is 177.03. That's my interest. So your interest is always going to be the difference between what you started with and what you ended with. Okay. All right, any questions on that particular problem? And I know we're going really fast today, so it is going to be important that you go through, you watch the videos that go with the packet, you email me with questions. If we have to have another session later, I'm actually kind of free this week, so if we need another session later in the week to kind of solidify concepts, you just need to ask. So, okay, let's go to one more compounding problem before we move on. Assume a $2,000 deposit compounding monthly for 8 years with an APR of 1.5%. How is this problem different than the last problem? It's monthly, exactly. So that's going to change our end value to 12. So when I shove this in my balance formula, I'm starting with $2,000. I have 1 plus my interest rate is 1.5%, change to a decimal. Now I'm going to divide that by 12. And then in my exponent, I'm taking that 12 because of monthly, and I'm multiplying it by 8 years. So some of you might say, well, I know that 12 times 8 is 96. Fabulous. If you would rather do that, you can change that to just make that 96 from the very beginning. You want to be careful about this piece here. If you divide that out and you round, right? If you round in the middle of your problem, you're going to change your end result, which could cause issues in web work. So you really don't want to round until the very end. But let's see what our calculators will spit out for that. $22.54.82 is correct. Okay. And again, if you're not getting these in your calculator, send me a picture. I'm going to say it a million times because I want you to do it. All right, so there's your balance after 8 years. Remember, your interest is your ending balance minus the beginning balance. So what is the interest for this particular problem? Yep, $254.82. So you take the ending balance of $22.54.82 minus the beginning balance of $2,000, and you're left with the interest that you earned over those 8 years. Okay. Questions right now about compound interest? Okay. If you have any, right, again, email, because I know we're flying through this. We have one more topic to discuss in this section before moving on to section 21. And that is called the rule of 70. It's also sometimes known as the rule of doubling. So if something compounds annually, so that's the key, it has to compound annually, you can approximate how long it will take to double by simply taking 70 divided by the percent as a percent. And that will give you the number of years that it will take to double. And it doesn't matter how much you start with. So whether you start with $20 and you're doubling to 40, or you're starting with $10,000 doubling to 20,000, because your interest rates are in percents, it doesn't matter. Okay, so let's do a problem. And this is also 70 over P is on your formula sheet as well. How long will it take for money to double? Again, see, it doesn't matter how much money, just random money to double if the APR is 5% compounded annually. So again, you have to be compounded annually. As soon as you see the word double, you want to think rule of 70. So we're going to take 70 divided by the percent. What is the percent in this particular problem? 5. So we would, forgot my part there, so we'll take 70 divided by 5, and we would get approximately 14 years. So if there's an investment, right, some guy says, I can get you 5% compounded annually, and you're like, okay, I'll invest $10,000. I don't know who has $10,000, but let's pretend. So you invest $10,000 at 5% compounded annually. In 14 years, you will have $20,000. And there you go. So this is approximate. It's not exact, but it'll give you a general estimate, which is basically what we want to do. So that's the rule of 70, which is in that section. I just wanted to just bring it up because some people get to that and they're like, oh, I don't get it. So at least you've seen it once. There is another video, of course, that talks about that as well. Okay, any questions about section 20? We have officially covered 2 of our 4 sections today, which is not too shabby. Okay, so let me switch PowerPoints. So module 12, here we go. Current slide, change the settings, and we are into loans. So now we're back to bad interest. So when you buy a car, a house, a boat, an island, I don't know, a child, whatever you want to buy, that you're going to finance, right? I just bought furniture. So here we go. So anything that you're going to buy and you're going to finance, and I'm buying windows next month. Anyway, you can estimate things using Excel. And I say estimate because, you know, banks or places where you get loans, whatever you want to call them, you know, they have more detailed things that go into it. You know, they check your credit score. They check how many credit cards you have before they loan you money. They check all kinds of things. So it's more than just a simple Excel formula. But this is a good general idea. So before I bought my house in February, I used this. I went into Excel. I knew it was an estimate, but I knew what I could afford in terms of rent every month. So working backwards, I thought, okay, if you know, these are the interest rates I'm finding on the internet. So how does that all fit together? So we have 2 Excel formulas that are going to come to light here in this section, and then a third formula that comes in section 22. And they're all very similar. Excuse me, the difference comes in the beginning letters. So remember that math people are not very creative. So the front letters of these Excel formulas discuss what you're trying to find. So here in the top formula, let's say you want to buy a house and you found your dream house, and that dream house is $120,000. So that's the amount that you want to borrow. So the number of payments, maybe you're doing it for 30 years. Well, you make 12 payments a year because you make house payments monthly. And you're going to do that for 30 years. And then you got to find your monthly interest rate. I have no idea what the going interest rates are for houses right now, but let's call it 5% because I'm lazy. And you turn it into 12. So if I would type this into Excel using equals PMT, it would spit out an approximate monthly payment based off of that information. So if you're trying to find, this is what you want to find. If you want to find the payment, you use the PMT function. and we're going to practice with these in a little bit, so don't worry. Where I used the second function when I went to buy my house because I knew I was paying $750 a month in rent. So I knew I could pay $750. I knew that was an okay payment. I knew that I probably was going to go 30-year mortgage. And again, you know, whatever interest rate you could find online, and you divide it by 12. So the PV is if you want to find the value of your item. Okay, so in my case, it was a house. I typed this into an Excel, you know, and it spit out, I don't know, whatever it spits out. I don't even remember at this point. It's been so long. But that just gives you a general idea. Now, that doesn't take into account taxes and insurance when you're buying a house, but it gives you an idea of what to look for, right? There's no reason for me to go on Zillow and look for $400,000 houses when my upper budget is 120, right? Or anything else. You know, I have a friend, like, she loves to just go on Zillow and look at $1 million houses. To me, that's just mean because I know I'm never going to afford that. And I don't know that I'd want one. That's a lot of bathrooms to clean. So those are the two Excel formulas that go in this section. So now we're going to do some problems. We're going to see how they fit in. So we're done with Sarah. We're on to Stacy. Stacy, this problem is dedicated to you. So Stacy wants to buy a $220,000 house. She has a 20% down payment, a 4% interest rate, and a 30-year mortgage, right? Yeah, so this is, Stacy, this is your life. There you go. We'll do a little. Okay, so with this information, we know that Stacy has 20% for a down payment. What is her down payment? How do we figure that out? And this is, if you ever want to buy a house, I don't know you guys' life situation, so I don't know if you have bought a house, want to buy a house, but this is kind of the stuff that you want to think through when you're going through it. Trisha, that's good math. Let me get a pen here. So because it's 20%, we're going to take 20% times that 220,000. So her down payment is how much? It's $44,000. Exactly. I mean, I know that just like you guys, I have $44,000 in my pocket right now, right, for a down payment on a big house. All right, so we pay $44,000 for a down payment. Okay, next question. How much is Stacy going to borrow for this house? All right, so Amber, ooh, let me go back up. No, Trisha, we are not going to borrow $220. Yep, there you go. $220 is the purchase price. You're going to pay $44,000 up front. So if we change color, if we take the purchase price and we subtract the down payment, what's left is the amount that we have to borrow, which, as Amber mentioned, is $176,000, which is kind of nice. The less you borrow, the lower your payment. But you did just cough up $44,000 at the beginning. Okay, so you're going to borrow $176,000. So now we get into letter C, which is what would we type into Excel to find this monthly payment? Okay, so think this through. We want to find the payment, so we're going to use the PMT function. So we start with our interest rate, 4%. So I've got my 0.04. But because we make monthly house payments, I'm going to divide that by 12. In the middle, we've got a 30-year mortgage. So again, I make 12 payments a year, and I'm doing that for 30 years. And then at the end, I'm borrowing $176,000. Notice there's no comma in that $176,000. The commas only go between the interest rate and the number of months, and then the number of payments and the ending. Excel sees those commas as new information. And if you put a comma in the middle of that number, it's going to classify it as new information. Okay, if you type that into Excel, it's going to spit out at you $840.25. So that would be the monthly payment for Stacy. Okay. All right. So And you guys can try this in Excel. You will play with this in Excel, I believe, in your web work homework, I think. Okay, for the exam, you're just going to need to know the difference between the formulas, basically. For letter D, what is the total she will pay back in her mortgage? If she's paying $840.25 every month, how do we figure out the total amount she's going to pay on her mortgage? Trisha, that's perfect math, and I appreciate that you typed it in there. So she's typing, well, I guess you had a typo, $840.25. That's okay. That's per month. She's going to do that for 12 months in a year for 30 years. So monthly payment times 12 months in a year times, so I mean, just think that through. If I'm making this payment every month for 30 years, how do I find that math? So if I multiply all of those together, I'm going to get $302,490. That's her total payback. Okay. I need to change colors. She borrowed $176,000. She paid back $302,490. How do we figure out her total interest? Just like we did with the last section. Right. So we're going to talk about total payback minus the amount borrowed. Because anything that you pay back more than what you borrowed is interest. So if she borrowed $302,490, but she only borrowed $176, the difference between those is interest, which is depressing, right? $126,490 is interest. This is why banks want your mortgage, because you're going to basically buy two houses from them. You know, you can buy a really nice house in Fort Wayne for $126,000. I don't know about Warsaw. I don't know this housing market. I live in Fort Wayne. You buy really nice. I did not pay that much for my house, and my house is 2,600 square feet. I mean, and it's nice. I mean, it's a nice house. So you can, it's just crazy. All right, but that's all interest. Now, with that being said, this assumes you only make the minimum payment every month. If you pay more, like if you would round up to $850, your balance, your principal would go down faster. You're going to pay less interest over time, right? So you always, if you own a home, you always want to round up and try to pay a little bit more, even if it's only an extra $5 a month. That can make a huge difference over the lifetime of your loan. And we do have an Excel assignment that goes with this. We're not doing it this semester, but if any of you are looking to buy a house or you want to play with that because you're interested, let me know. I think it's kind of cool. It's kind of cool. Okay, this section is taking a little bit longer for me to talk about. Okay, we're not doing that one. Okay. All right, we're going to do this problem, but I have to back up one. So the total expense ratio, I don't want to go over this too quickly, but this is in your packet. I don't remember what page it's on. But this is a generalized statement. Again, banks and financial institutions go into way more detail on how to figure out how your monthly payment is calculated. But if you want to get a general idea of what you can afford, you would take 36% of your monthly gross income, right? That's before taxes. You subtract your monthly home bills, talking about insurance and taxes, things that you have to pay on your house. And then you subtract your other monthly bills. So do you have student loans? Do you have a car payment? Do you pay child support? Do you give $100 a month to your mom because she's your mom and you owe her money? I don't know, right? So any other monthly bills that you pay on a regular basis. Okay, that's kind of what you want to think about. And then you figure out that's how you figure out the monthly payment you can afford. All right. There are other ways to do it. Like when I did it, I said, I know I can afford $750 because that's what I'm paying in rent and I could live on that. So I typed that in and went from there. So, okay, let's erase that and do a problem. Okay, so Bob earns $48,000 annually. The area he is looking to buy has property taxes of $1,000 a year, and he anticipates $800 a year for insurance. He has a $350 monthly car payment and pays $80 a month for a gym membership. So how much of a monthly payment can he afford? So this is where we're going to use our total expense ratio to figure out what he can afford. Okay, so first things first, I don't like the color of pen I chose. There we go. So we're going to start with 36% of his monthly gross income. What is Bob's gross income? Remember, it says income before taxes. What part of that problem is income before taxes? Have I lost you guys? Are you still there? Can you hear me? Okay, well, I guess I'll just keep talking. So 36% of the monthly gross. Oh, timeout, sorry. My chat screen was not scrolling. So I apologize for thinking you guys were ignoring me, because you weren't. I missed a lot of stuff in that. Okay, yeah, so a couple of you wrote it some different ways. We take our 48,000 divided by 12. So some people put in the 4,000, because that's what it is if you divide by 12. Or you can type it that way. Good, thank you. And now we're going to subtract our monthly housing. So that's taxes and insurance. So we pay 1,000 plus 800. So that's 1,800, but that's yearly. So how do I change this 1,800 yearly into monthly? I divide by 12, as many of you already know. Okay, so that's our monthly. And then the last piece is, what else is he paying? $350 for a car, $80 for gym, and that's per month, so that's just minus $430. So that's kind of your general setup. I usually write it out like that first, and then I go back and I do my sections. So how much is this first section? 36% of the 48,000 divided by 12. $1,440, exactly. So we take $1,440, we subtract our middle section, which is $150, and then we subtract the monthly payments of $430. So in this example, after we do our subtraction, how much can Bob afford for a monthly payment? $860. Exactly. Okay, so if Bob's like, okay, I feel good with $860, then we go to part B. The bank will give him a 4% interest rate for 20 years. So he wants a 20-year mortgage. So what is the value of the house he can buy? So this is where we would use the PV function in Excel, because we're trying to find the value of the house. So present value starts the same way the PMT function does. Interest rate divided by 12, 12 months in a year times 20 years in the loan. He can afford an $860 payment. Notice how this last piece in all of these functions is negative. Just FYI. If you don't put the negative sign, it will just show up red and in parentheses in Excel. If you type that into Excel, you will find $141,918.80. So when Bob goes on Zillow, he should be looking for an upper end of about $140,000. Anything above that is going to get him a little bit out of his comfort zone. Okay, so that's an example of using the total expense ratio and using the PV function. All right. Whew, that's 3 sections. I feel like I'm just going 500 miles an hour, so I hope I'm not losing you guys too much. But now we're getting into retirement. So we've invested money, we've spent money on credit cards, we've bought houses, And now we are going to save for retirement. So we also have an Excel formula for this, and you will see the front letters, because we said, the differences in the letters. The front letters is FV, which stands for future value. So think about when you invest in terms of a 401k or a 403b, something like that, you're investing for your future. So you've got the future value. Pretty much the same. You still have your monthly interest rate, number of deposits. Are you doing it per month for a number of years? So it looks very much like the mortgage piece. And then the amount deposited per period. So if you're putting this in every month, then you would type in the amount, $100 a month, that would be 100. Okay. So, all right. So our first question that we are going to look into answering is, how does a 401k contribution affect take-home pay? Because you may or may not be aware, right? The 401k contributions come out pre-taxed. So if you invest in a 401k, it reduces the amount of taxable income, and therefore you will pay less income tax, which sounds great up front, but later when you take money out of your 401k, the money is taxed at that time. Now, the reason why this kind of makes sense is, well, let's pretend that you're working right now and you're making $50,000 a year. So that puts you in a certain tax bracket, and I'm not going to pretend like I know because I don't. But so you're in a $50,000 tax bracket right now. You're going to pay a certain percentage of taxes. Well, when you retire and you're taking money out of your 401k, you're probably not making $50,000. You might only be taking $20,000 out of your 401k a year, and therefore your income is only $20,000, so you fall in a different tax bracket, so you pay less taxes. That's the whole goal of this piece, is that you'll be in a different tax bracket later, and so you'll pay less taxes. That may or may not be true, but that's the goal. So we're going to do a little problem here in this one. Okay, so to see how it affects your take-home pay. So Tim earns $48,000 annually. He pays 18% in taxes. That's his tax bracket. How would investing $150 into a 401k impact his take-home pay? And there is the first page of this section has an example like this too, but I think it's really interesting. So before investing, and I'm just going to talk through this, his gross monthly pay is $48,000 divided by 12, right? So his gross is $4,000 a month, right? Again, that's before taxes. Now, before we actually tax that money, we take out his 401k contribution. Well, remember, this first part that we're doing, he's not putting any money in. So he has no contribution. So his taxable income is $4,000. Okay, think through mathematically. If he's paying 18% in taxes and he's got $4,000, how do I figure out how much he's paying in taxes? Can anybody help me out there? Exactly. We take 4,000, we multiply by 18%. So when I do that, I end up with, oh, I don't think that's the right number. I got two different numbers written down. 720. Thank you. Because I have two different numbers in two different colors, and I don't know which is which. So taxes are $720. So the take-home pay for the month is $3,280. Right? Not bad. A lot of people say, I can't invest in a 401k because I live paycheck to paycheck and I need every penny. I get that. I did that for a lot of years. But look at this. So in this part, we're investing $150 a month. Logically, we think that our take-home pay would be reduced by $150. But watch what happens. Our gross monthly pay is still $400. But now we're investing $150 in our 401k. So we're not losing that money. We're just putting it somewhere else. So therefore, the taxable income becomes $3,850. Right, we only tax, right, the taxable income. So again, now we're going to do the same thing we just did. 18% of the $3,850. How much is the investing Tim paying in taxes? What's 18% of $3,850? $693. Thank you, Stacy. So now when I take $3,850 and I subtract $693, my take-home pay is $3,157. So now we can compare take-home pays. Of course, it's less. I mean, you put $150 in your 401k, your take-home pay is going to be less. But how much less is it? It's $123 less. Yeah. So I think that's actually the next page. Do you guys have that written down that I can move to the next page? Great. So the difference in take-home pay, where's my pen? So you just said it's $123. What's the difference in taxes? Look at the difference in tax pay. How much less did he pay in taxes? $27. Yeah. So this is where, okay, so the less was 123. The difference in taxes was 27. This is where the humor me comes into play. You will pay $27 less in taxes if you invest $150. I just want to see what percent that is. Can anybody do that, solve that proportion for me real quick, like, or real slow, like, I don't care how fast you do it. Stacy, that is not correct. Remember, we're cross multiplying and dividing. So 27 times 100 and 150 times x. So 2700 equals 150x. Divide both sides by 150. James, you're absolutely correct, and that's 18. Where did we see the 18 before? Do you remember? It was tax rate, right? And that's not a coincidence. So if you think about the interpretation of this, for every $100, because percents are out of 100, so for every $100 you invest in your 401k, that's how many dollars less you will pay in taxes at that time, right? You're going to pay it later, but at that time. So Tim invested 150, which is, I mean, that's 1.5 times. That's where the 27 came into be. So if you're looking at, okay, then how is that going to affect my take-home pay? Look at the difference between these two numbers that I just arrowed. The difference between 150 and 27 is 123, which is the difference in take-home pay. So if you're thinking about investing in a 401k and you want to know how this all relates, it's just a beautiful mathematical problem is what it is. Okay. All right. That, we're down to 2 minutes. I have one more example that we can go through, or it's pretty much, or we can be done. You guys have a preference? Let you guys vote on that. Okay. Yeah, and these sections aren't too bad. Of course, there are more videos to go with them. So I do recommend, watch them as you go through. If you get stuck in web work, shoot me an email. I've got plenty of videos, or I can make new videos if we need them. But reach out if you have questions. We'll kind of go from there. One thing that I did not get to is that Project 3 is a financial project, and it really goes with this stuff. Next week is a lighter week, so we'll talk more about Project 3 next week, but I don't know what your schedules look like. So if you have time this week, you might want to start looking at that. Exam 2 was last week. I got those graded. Most of you did very well. Very well. You guys actually did very well. So check out those grades. Let me know if you have questions. I'll post some different videos about Excel help. I'll see if I have any project help videos. I'll post whatever I have in the announcements. If you can't find something and you need something, you know where to find me. So have a good week. Thanks for attending and participating. And yeah, let me know if you need anything. I'm here for you. So have a good week. Thanks, guys.